Hello everyone. In this video I am going to demonstrate modulation of a data signal using a 48 kHz high frequency signal. So as you can see, I am using Arduino Uno to transmit the data. So as you can see here, Arduino Uno is sending serial data. So this is the transmit pin of the Arduino Uno. You can see this is the transmit pin of the Arduino Uno. You can see the TX pin. So from the TX pin, I am sending serial data. I am sending alphabet R continuously from this pin at a delay of 1 second. So as you can see, this is the Arduino Uno. So from the Arduino Uno, the data is sent to an optocoupler. So as here you can see, this is the optocoupler MCT2E. I am using optocoupler MCT2E. So data is arriving here. You can see the LED is flashing. So at the output section of the MCT2E, I am taking the output sample. This optocoupler is just used to separate the high frequency signal and the data signal. So we are not going to mix the two signals, two interfaces. We just want to keep isolated the two interfaces. That's why I am using this optocoupler. So I don't want the Arduino Uno to become a part of the modulation circuit. That's why I am isolating this using this optocoupler. So as you can see from this optocoupler, this is the output coming and I am feeding it to 555 timer IC. The 555 timer IC is wired in astable multi-vibrator mode, and the input signal, the data signal, is arriving at pin number 4 of the 555 timer IC. From the pin number 3, we are getting the modulated signal with a carrier frequency in it. You can see my previous videos where I have generated the carrier frequency, and very good videos are there for carrier generation. So this is an ASK signal, amplitude shift keyed signal, amplitude shift keying signal, ASK signal. So in other videos I have already discussed about the ASK signal. Please watch the other videos for the ASK signal generation. So as you can see, this is the ASK signal coming, and this ASK signal, so from here pin number 3, the ASK signal is coming, and the ASK signal is fed to, you can ignore this wire is not used anywhere, just we will ignore this wire. So from pin number 3, ASK signal is coming and it is fed to this demodulator. So as you can see here, the demodulator is using 0.01 microfarad capacitor and 400k resistances. So effective resistance is 25k. So this is the demodulator. So the output of the demodulator is fed to this op amp. So here there are two op amps I am using. This is op amp LM324. One of the op amp I am using as unity gain buffer, and the other op amp inside is used as a voltage comparator. So after comparing, the final voltage is fed again to another optocoupler. So as you can see here, this is the second optocoupler. So this optocoupler is interfacing the modulated data. After demodulation, the data is fed to Arduino Uno using this optocoupler. So basically the data here is 9 volt DC supply. So 9 volt DC is not compatible with Arduino Uno. That's why I am using this optocoupler here. So from here you can see finally the data is reaching to the Arduino Uno. So this is another Arduino Uno. So this was the first Arduino Uno and this is the second Arduino Uno, the receiver Arduino Uno. So let us look at the performance of this circuit. So if we look at in the console, we can see we are receiving alphabet R. You can see the alphabet R is coming. We can receive the alphabet R. However, we are receiving some error signals as well. You can see this at the rate, question mark. There are many error signals coming. But alphabet R is also coming. We are getting alphabet R, but we are getting some error signals. Let us look into the waveform and analyze the problem. So as you can see, this is the final waveform. So this waveform is after the demodulator, after the comparator. This is the waveform. And after the optocoupler, this is the waveform getting fed to Arduino Uno. So here we can see, let us ignore this waveform, this high pulses, these glitches. These glitches I am going to provide a filter and I will omit these glitches. But here you can see the time period is very short. The effective time it is staying high is very low. It is very low. So I feel this is the possible reason of error in the circuit. However, I will not conclude the reason now. Let me first put a filter and let us first clear this waveform. You can see there are glitches in this waveform. So I want to remove this waveform. So I will provide a filter and I will remove these glitches. Then later on we will analyze this waveform. We will analyze the data quality. So in the next video, again I am going to do some improvements in the circuit and I will come back with the next video. So thanks a lot. Thanks for watching.